Hello and welcome back. My name is Corey and you're my rubber ducks. And today we're continuing our series where we are creating Tang. It is a template language, hence the name Tang, and we are writing this programming language from scratch in a terminal window using Vim as our editor and using modernish C++, Bison, Flex, ICU when we get there, and things like that. And we have been slowly developing this language, adding features to it, and of course, because we're writing it from scratch, if we don't write it, it doesn't exist. And the most recent feature that we added was we added arrays into our language, and we added indexing into the arrays so that we could access the elements of it, and then we added assigning values to indexed items. And so that's where we are picking up at this moment, is that we need to now sorry, my brain's a little I'm trying to come up with the right words. It's the end of the day. But we want to now look at what happens when we pass this array into a function and maybe modify it. And it is the problem of the old problem of copying by reference versus copying by value, and what's the most efficient way to get this done. Why do you make certain decisions? So we're going to start and make sure that the window is occupied. Oh, I'm in source. I should not be there. I should be in Tang. And if I say git log, you see that the most recent change was indeed episode 42, the previous episode. And if I say git status, there's no changes. So as always, nothing up my sleeves. I haven't pre-prepared this, which means you get to see all of my mistakes and everything, because this is true 100% live coding. This is how I would go about solving these problems. And no, I actually haven't pre-planned this. I don't know how I'm going to solve the problem. I just know that it needs to be solved. So let's first, in our test program, let's write an example of what the problem is. And I believe I can, let's do this. That was just to get me a copy. There we go. And what I'm going to do, I started doing this in the last one. I'm going to put these in brace and close, and I can just, if I hit the equal sign, it should, well, kind of. It didn't indent that stuff there, because it's inside of a string, and of course it wouldn't mess with the string if it's in an indentation. If it's trying to indent stuff, it shouldn't have messed with the string. So anyway, okay. So we've got this, and I'm going to say function pass by value, and the reason is because verse ref. The reason is, if I have this, and I'm just going to say this condition is going to be there. I'm going to pass in a val, and all I'm going to say is val sub 1 is equal to foo. All right. Now, I'm going to, let's have our b is equal to, let's call this change. There we go, change. That way I can use a here. And the reason I'm wanting to use a, no reason other than, there we go. We're going to say 1, 2, 3. And if I do print 1, That is not what I meant to do. Let me just delete all of that because that was messy. Print a sub 0. How about that? Print a sub 0, a sub 1, and a sub 2. And there, we've done it twice, and now in the middle we're going to call change a. Okay. Now what would you expect to happen? Well, in fact, this should just be passed by value. What should we expect to happen? Let me grab this here. And this should be P1. We would expect it to print out 1, 2, 3, 1, 2, 3. Okay? But the problem is when we call change A, we're passing in A, and it should be A sub 1 is equal to foo. And what I'm pretty sure is going to happen is that when it prints out this one right here, A will have been changed in the function, and we don't want that. We don't want the function changing things. So let's run this and make sure that the test fails. So clean. Test watch. Good. Compiling everything from scratch. And now, while it's doing this, I'll go back to our code and say, why do we expect this? Why should we expect it to be 1, 2, 3, 1, 2, 3? And the answer is because, well, when we're passing this value into change, it should be passing by value. But the way our program works is that we just peek the value from its place in the stack and to put it on the stack. And yep, we see the problem right here. It's printing out 1, 2, 3, 1, foo 3. So in essence, what we have is we have a pass by reference, and we don't want to pass by reference. Now, it might be easy to say we should always just pass by value, but that's not the most efficient thing to do. And now I'm going to put this back, versus ref. Okay. You want to pass by reference when it's safe to do so. How do you know when it's safe to do so? Or why, first of all? Because it's more efficient. You're not having to allocate stuff. And if you have a vector of 15 things, and maybe it's a multi-dimensional vector, it's faster to pass it by reference. But if you need to change something in it, you have to all of a sudden copy the entire thing. And yeah, that's our choice at the moment. That's what we have to do. So there might be more efficient ways of doing like partial copies or something, but right now we're going to do one or the other, either pass by value or pass by reference. And so we need to detect now. We have to write something. Again, if we don't write it, it doesn't exist, this language. So when we are compiling a function, we need to know, is this val going to be written to? That's what we need to know. How do we do that? That's a good question. Well, let's go to I want to check the code. When we call a function, so where is that going to be? That's going to be in our source AST node, which one? Function call? Yes. So when we call a function, what does the compile look like? Well, we've got, well, the compile preprocess we only run the compile preprocess on oh wait, this is calling a function. Sorry, never mind. But what we do when we actually do the compile, for each argument that is being run, we run the compile for it. And then we push the function onto the stack. And then have the bytecode for calling the function with size. And what would be nice is to add if the argument will be altered within the function body, then copy the argument. Create a copy of the argument so that the value is not changed outside the scope of the function. Okay. That's what we want to do. And so now we need to say, well, how do we know if it's going to be? If I don't know, so I don't know that at this point because the function, because we've got this kind of functional reference thing. What I mean by that, a function is a value that can be passed around. So I don't know if we have a open parentheses 1 comma 2 comma 3 whatever the arguments. I don't know what kind of function it is until runtime. So it really needs to be the function execution. So when I execute the function, that's a better way of doing this. Okay, so I'm going to edit the source program execute, and is it call func? So let's see, what all does call func do? Compiled functions make use of the arguments on the stack. They'll clean up the stack when they finish via the return opcode. So the computed expression compiled function, all that it has is 2 arguments. What are those 2 arguments? This is actually getting more complex than I thought off the top of my head. And that's why you're my rubber ducks. As I'm explaining it to you, I'm understanding the problem more deeply. So the computed expression compiled function should verify that the correct number of arguments has been passed. Okay, I don't like this. I don't like doing it here. I think it should be as part of the function compile, that the first thing that it does is it makes a copy. Yeah, that's what it needs to be. My opinion. Yeah. So not in this one. I need to edit the source of AST node. Do I call it compiled function or function compiled? Function declaration. Yes. So where is that? In the compile, first of all, we jump past the function bytecode that we're about to compile. We prepare, and this is where, okay, so when we push the environment, one of the things I think that we need is the environment needs information about which variables should be copied versus, or which variables are going to be altered. And then if those variables are the names of an argument, then we should run a command that will copy. Yeah, that will make a copy of it. That's what we should do, or convert it to a copy. So if I've got an array in stack position 1, as I'm thinking of it, and I think of it, the stack going down, whatever. I don't care which direction you think of the stack growing. If it grows down or grows up in your mind, doesn't matter. But in stack position 1, if I have a vector, then I want to have an opcode that will then say, take that, do a deep copy, and put that in its place. And that will work. Okay. So we're going to prepare for a new function environment. And that's this code block. Ensure the arguments are listed as identifiers in the order that they appear. That's fine. Save the start position of the function. We want that. Reserve the stack positions for any variable in the body that is not in the arguments. That's fine. Put the string literals on the stack. Compile the program. And here is where we want to say, so I'm going to remove that. Haven't made any changes. It's just right here. I'm going to put this little line of thing, and let's change it. So if the argument will be altered, hey, I think the comment will work from here. If instead of if any argument will be altered within the function body, then create a copy of the argument so that the value is not changed outside. So that the value is not changed outside the scope of the function. Sure, that's good. So how are we going to do that? Well, let's just kind of hallucinate something that might already be there. This arrow arguments. So I'm thinking about this. I'm just trying to say, what is this arrow arguments? That's is that a vector of strings? I'm in the function declaration. Okay, and didn't I just open this? So this is going to be the AST node function declaration, and it doesn't tell me the private members. I wonder if that's a setting in Doxygen that we can document private variables as well. That would be handy to know. Include AST node function declaration. So we've got the name of the function, the arguments that are expected to be provided, and there that is a vector of strings, and then yeah, the code block. Arguments dot size. Okay. And what am I doing? I'm just going through and I'm saying if okay, so what this is supposed to do right now is I'm going to say it from the perspective of it passed through the if. Say the argument will be changed, will be modified in this function. Make a copy. Create a copy of it. So that the changes will not leak into the parent or into the calling scope. Okay, that should work. And how are we going to do that? We're going to do a program dot add bytecode. What is this type? Integer underscore t. Opcode, we're going to make up copy, and that is going to take program.add bytecode. Where are we copying? Which one is a copy? And this needs to be the stack position. So how do I know what the stack position is? This is for the strings. So when I push the environment, it's going to create a new, whatever it is, add identifier. So it's the location of an identifier. How do I know where that is? So program.add_identifier. And I just don't want to lose where I am. So when I come back, it's going to be some program.something. and I don't have that open. So edit source program.cpp, add identifier, and oh, the identifiers dot name, or yeah. So if I say get identifiers, and that's returns the map, and just get the dot at of the name, it'll tell me its location. Well, that's simple enough. So right here, I'm going to say program dot, I'm in the wrong place, get identifiers dot at this, no, the argument, this arrow arguments sub I. Yeah. So I'm creating an opcode that will say the stack location. So copy and copy some stack location. We haven't created this copy opcode yet, but okay, that's what we're going to do. So the only thing that we need to do now is we need to create the copy opcode and create this check. How do we know if a variable is going to be changed? We need to track that somehow. That's all right. So I'm going to go ahead and hit save, and it's going to not compile because it's not going to like that empty if expression, and I don't care. I'm going to go ahead and finish the opcode part of this. So I'm going to edit the include opcode, and we've got our pop, peek, poke, and now we're going to have a copy. And what does it need? It's going to say get so stack number from the frame pointer. And we're going to deep copy val at stack number store at stack number. That's what that is. Now edit the source program dump bytecode, and that's after peek poke copy. So peek poke and this should be copy. Okay, we need one more, and we'll just say copy, and what are we copying? That's all that we had to put for the dump. Just thinking quietly, I should be thinking out loud. So program-execute. Again, we're going to have the peek, poke, and then copy. So there's poke. And now we need a copy. And execute program check. That's fine. The position, that's fine. The stack check needs that. Okay. And is going to equal stack.back, and that's going to resolve to a garbage collected value, and we should be able to call make copy. But I don't think that that exists yet, but we may have to add it. All right. I am going to just since I added an opcode and things are going to change. So it's still not going to like our empty if statement. I don't care. The copy should be correct. And did it compile this yet? No, it has not. So it may not like it. I may have to add that. In fact, there's a very quick way of finding out. Let's go to garbage collected. And is there a make copy? There's a lot of operators. Oh, there's a make. And I think we need to create a make copy. Let's do that. So we're going to edit the include garbage collected. We've got our copy constructor, move constructor, copy assignment, move assignment. There we go. Let's put it right here. And we're going to say create a separate copy of the garbage collected value. And it's going to have an return of the garbage collected copy of the original value. And oops, didn't want to do that, but okay, separate copy of the original garbage collected value. And now, so this is going to return garbage collected, and it's going to be called make copy, and it's going to be const, yes, because we're not changing this one. And all that we're going to do is we are going to return this arrow ref arrow make copy. Uh-oh, it doesn't like that. This is probably, nope, didn't mean to do that. Okay. So computed expression is probably at this time so the problem is garbage collected includes computed expression, and computed expression includes garbage collected. That's always a bad thing. So let's find out why. So it's not saying that it can't, that I'm calling it wrong. It's saying that at the point of, sorry, at this point in the compile, we don't know about the structure of computed expression. And I know this is a separate issue, but it's one that you have to deal with when you're including files. How do you make sure that everything is available? Of course, one of the easiest things would just be the only thing that is templated is the make. So could I move everything else out into a .cpp? I mean, that should work. Include computed expression .hpp. Let's look at it. And we've got computed expression, computed blah, blah, blah. And then we've got our pound include garbage collected, but it should hit our if in def. And since it's defined, it should skip it. And oh, it's happening in this order. So we are computing, or we're trying to compile AST node. AST node is pound including program. Program is including computed expression. Computed expression says, hey, here's my 4 declarations, just promising I'm going to tell you about these, even though we don't have it yet. And now include garbage collected. So it's not the problem of compiling the garbage collected .hpp. It's just the fact that it's doing it in this other order first. If in AST node, for example, or even program.hpp, if I included garbage collected before computed expression, it would compile. Yeah, it would, but I don't think that's the right way to solve it. I think the right way to solve it is to edit a source / garbage collected .cpp. Oh. Garbage collected yeah. Okay. This is garbage collected. So why? Oh, I know why. All of these are. So I put these here, and I should not have. So here's what we're going to do, and it will solve the problem. All right, and whoops. All right, that should be fine. And now this One more. Okay, it should compile. Well, I mean, we still have an empty if statement. We're just fixing other stuff, worrying about other stuff. And I want to move these out as well. But I'll worry about that in a moment. Okay, so no, we're to the point we need to worry about it. Right now we've got it making a copy. It's still broken. I know why it's broken, but I want to get to where we're making the copy first. In fact, I'm going to close this garbage collected. This one as well. I'm pretty sure that we're done with the execute. Pretty sure we're done with the bytecode. Pretty sure we're done with this one. I'm just cleaning up so I can get down to what I want. Let's look at the program.cpp. Not the add identifier, but the sorry. Well, drat. Allergies are kicking in and my nose is itching. But there's no no civilized way to address that when you're on camera. Oh well. You scratch your nose and it just looks weird. Anyway, all right. So when we push an environment, we have our identifier stack that we push back, our string stack, and then we've got our we forward all of the functions that we've collected. We push our break stack and our continue stack, and we run the pre-process on this. So what I believe we need is a prepare the, and we're going to have a identifier assigned stack. So a new stack that's going to be this push identifier assigned stack. So we're going to have something called push identifier assigned, and we need to pop it. So pop the identifier assigned stack. Pop identifier assigned stack. Do I need to call a push and pop, or can I just... I don't think so, because the whole point of popping these is so I could push something into it. So yeah, the identifier stack of this, I just push back something. So let's do this. Identifier assigned stack, that's fine. We'll just say push back an empty whatever it's supposed to be, and identifier assigned stack pop back. Yeah, don't need to pass it anything. Well, what is identifier assigned stack? It's going to be, it needs to be something that we can access. So I don't have the include for programs, so we need to do that. Let's go to the bottom, and we've got this identifier stack. Let's put it here. Stack of sets of identifiers that are the target of an assignment statement within the scope associated scope. I like that better. And all of this is going to be a standard, this can be a set of standard strings called, oh, no, this needs to be a standard vector of standard strings called identifier. What did I call this? Assigned. Identifier assigned stack. Okay, and so it's empty, and when the first thing, identifier assigned, we need to get it somehow. Add break, add continue. Do I have an add identifier? Add string. It should be add identifier. That's a bad name. Let's do one here that is add an identifier name to the set of identifiers, or maybe that's a little too, how about this? Indicate that an identifier will be altered within the associated scope. And it's going to get a param that is name, the identifier name, and it's not going to return anything. So it's going to be void add identifier assigned const standard string ampersand name, and then we want to have a get the set of identifiers in the current scope, identifiers that will be assigned in the current scope. That's fine. And at return, a set of identifier names that have been identified as the target of an assignment operator within the current scope. Okay, that's the goal. And that means we need to return a set of strings. And it's going to be get, no, didn't mean to do that, get identifier assigned. That should be a const, so this needs to be a const whoops, there we go. Constant set of constant strings. That's fine. Now, what did I call this? I know I'm going down, scrolling down. Oops, I just passed it. These are called identifiers assigned. No, identifier assigned. Identifiers. No. Identifiers assigned. Yes. And I'll leave that add identifier assigned, get identifiers assigned. Yes, I know one is singular, one is plural. It matches the semantics. We're adding one, but we are getting all of them. All right. We need to go back to program.cpp and write this. Add identifier add. Oh, that's why it shouldn't be add string. It's add string, get identifiers, add identifier. Okay, so I'm being consistent there. Let's put that there. So it's and what's this going to be? Void program add identifier assigned, and it's going to be a const string ampersand name, and all that we need to do is this arrow identifiers assigned stack dot back dot insert name. Simple enough. And then we have we are returning a set. Is that right? Yeah, a set of strings. A set of string ampersand. Where's the ampersand? There we go. And it's called program get identifiers assigned. And it can be a const. Did I declare it const in the previous screen? Let's find out. Return this identifiers assigned stack dot back, and it is, I did define it as a const. Okay, so we've got a data structure to hold these names, So let's go back to what's not compiling, and that is the function declaration.cpp and this if statement. So all that we need to know is if program.get identifiers assigned dot count, and what are we counting? This arrow something's not right here. What's not right? This arrow arguments. And what is this? This is I'm in the function declaration. I just want to look at something. Arguments is a vector of strings. Oh. So I could have done for auto const ampersand name in this arrow arguments. And now it's name name. Does that make sense? Okay, so going through the arguments, if the identifier is assigned, then the argument will be modified, create a copy of it so that the changes will not leak into the calling scope, add an op copy, and where the program.get identifiers at name. That's what we're thinking should happen. This will probably compile. Oh, never mind. It's not liking something. Function declaration at line 96. Is that where the error is? Okay. So static assertion failed. Must have a non-const, non-volatile value type. So the sets type can't be const. That's interesting. Six and 12. So all we have to do is in the get identifiers. Oh. And this should have been const. I'm going to have to rerun that compile because I hit save while it was compiling. That's a no-no. It's like, oops. And anyway, it doesn't like this. That's okay. Program.cpp. Oh, line 59. Identifiers assigned. And line 97 is going to be the same thing. Identifiers, copy paste issue. All right, so it at least compiles, but it's not doing anything. You say, Corey, what did we just write then? We wrote the basic part. That is, okay, so what is our code doing at this exact moment? When we try to compile a function or a script, try to compile a script, it will call the push environment, and the environment now has a new little thing, the identifier assigned stack. All right. Now, what is the point of this? Well, why do we need a stack? First of all, remember that it could be that a function is declared and it's got to compile that, and then it needs to no longer be compiling that function, but it whatever else is going on. Oh well. This is just to track what's going on in the scope that it's in. Okay, so we've got this identifier assigned, we've got this stack. We can push values into it, but we don't have anything that says when do we push something into it. And the answer is when we are on the left-hand side of an assignment operator. And how on earth do we know that we are on the left-hand side of an assignment operator? I'm glad you asked. We've got a bunch of changes that we need to do. A bunch. Sort of. Oh, what have I... Oh, test.cpp? Really? I'm going to add something here. I'm just going to say print val sub 1. Why? Because it should print. Well, I want to make sure that it's zero, 1, 2. So it should be 1, 2, 3, 1, foo 3, 1, 2, 3. 1, 2, 3, 1, foo 3. All right. I'm writing that. Still not going to pass. I know that. Yeah, because it's passing by reference. It got 1, 2, 3, 1, foo 3, 1, foo 3. All right, so I'm going to exit out of all of these. And now, what change needs to be made? Well, in our include for our AST node, our preprocess, compile preprocess, we need to push, we need to have some sort of value. Oh, this is going to be ugly. Well, basically, we need to be able to say something, and it is the the state of the compile, right? But I don't know if we only need this one. Or if we need multiple. What am I talking about? Maybe there's other states that we need to pass through. So what I think we're going to do is we're going to pass this. How did I do it with the ops? I want to edit the include for AST node binary. And I just did an enum, and the op is of that type, operation. Okay, that's fine. So we are going to have an enum that is the preprocess state. Yep. Param state. Any preprocess do I want to say it this way? Yes, I do. So any preprocess flags that need to be considered. Okay, and what does this look like? Well, we need AST node public. I think it has to be declared under public, and this is going to be preprocess flags to be preprocess flags. That's it. And this is going to be an enum called preprocess flags. And what's the first one? Is assignment. Can I do it like this? Is equal to 1? And how about empty? Default. And I never remember how to assign enum values. I mean, I rarely do this. So let's look it up. C++ enum assign values. I don't care. Just tell me what, yeah, blah, blah, blah. Yeah, equals something. Fine. Is assignment so I've got this preprocess state. I think I like that better. And we will say preprocess bit flags to indicate the preprocess state, the state of the preprocess scan as it we'll do recursively evaluates the AST. The default state, and we'll say indicates that, no, we'll just say AST node is part of an assignment. Expression. Okay. And now we need to add this to everything. So we're going to I'm just going to say include AST node everything. And there we go. So AST node.hpp is number 14. So we're going to start there. Buffer 14. The reason is because now we've got to go to the first one, and now %s making sure that that is correct, and we're going to replace that with this. Only needs to be done once. No. Let's undo that. Let's do it again. And I probably have to escape these. Nope. Doesn't like that. What did it do here? Compile process, program. That's not making any sense to me. Okay, never mind. Sorry, I don't have time to figure it out. I'm going to edit, include AST node, and I will apologize ahead of time for this. compile pre-process. There. So if I look for pre-process ww345p, right? So n5wp n5wp okay, I'm sorry, I told you this is bad. N5wp. I can probably do a macro if I remembered how to do macros. Oh, this one doesn't have it. 5wp. This one doesn't. 5wp. Next, 5wp. And if you're wondering, yes, I figure that there's faster ways of doing this. I just don't always know them because, well, I don't know everything. It's impossible to know everything. Next. 5W. Oh, nope. 4W. P. Okay, got them all. That's good. Now I'm going to exit. Why? Because now I need to all of the source AST node. So in the compile pre-process, we need to, oh, what's it called? Pre-process state. Okay, so I'm going to yank that because I'm going to need it a lot. And there. Nope, that is, it's only on the pre-process. There we go. Oh, that means I need to do the maybe unused in some of these. This one doesn't need it. But for each one of these, I need to say comma state, comma state, comma state. This one doesn't need it because compile preprocess, comma state, comma state, and we still are not even fixing it, fixing the problem. We're just getting to the point where we will be able to fix it. So this one is unused, so we need to be able to say maybe unused. Is it not going to like the fact that I've got preprocessed state and I don't have AST node preprocessed state? I don't know. So got a ways to go. Okay, we're working on it. And where am I? Oh, AST node. And I need to add a maybe unused there. Nothing there. Got it here. Nothing there. Nothing there. Okay. Okay, this is no unused. That's fine. We can edit that. This is source AST node function declaration. Sorry, just realized it's like, we've been in this. All right, any others? Did I only miss one? Well, where I call the function originally isn't going to have it. Yep, there we go. So that is in program.cpp. So source program.cpp line 62. And we just need to push in AST node default. Will that work? Oh, I took it. Yay, that's good. Okay, so now we've done a bunch of refactoring and we have no new functionality. Hooray. But now's the good part. So we're going to edit the binary. And this is the power of recursive stuff. AST. So edit the source for AST node binary. And in its preprocess, the left-hand side is going to get the state and a bitwise OR of node, not node, AST node, what did I call it? Include AST node.hpp. Is assignment. Where am I? Binary. Oh. Is assignment. Will that compile? From int I just want a bitwise operator. Is there a better way of doing that? Or is there a more modern C++ way of doing a bitwise modern C++ enum bitwise operator? Oh. So okay, just removing that one. If I go to buffer 27, enum process state int which one is it not liking? preprocess state from an int to, oh. Is that the same error as I was getting before? From int to preprocess, from int to preprocess. So binary, oh, 3. I'm just wondering is if I can yeah, just tell it, yeah, this is what I was intending to do. Now again, this isn't doing anything. It's compiling. But what we've done here is we've said, okay, in our compile preprocess, when we do the compile preprocess for the left-hand side, the state variable is passing in this flag of is assignment. Is true. That's the point of this. That's the goal. All right, so now where do we care about this? We care about this when we get to an identifier. So if we get to an identifier, let's say edit the source of the AST node identifier .cpp, and the compile preprocess, we add the identifier, and then we're going to say if state or AST node is assignment. Is that the name of it? I think so. Yeah. Identifier appears on the LHS of an assignment expression. So do I want to say report or record or indicate or inform? Inform the current scope that, yeah, I'll do it that way. Inform the current scope the identifier will be so that any necessary actions are taken. All right, and now what are we going to do? We're going to say program dot add, or is it add or set? I'm in 15. Let's just go to 26. After pop environment, we've got compile, add identifier assigned. That's what we need. Add identifier assigned. Go back to buffer 15. Add identifier assigned this arrow name. No compile errors yet. All right. Now you say, we broke other stuff, Corey. What's the deal? I don't know yet. We'll figure it out. And you hear that? My fan is going off like crazy, so that means something's really broken. So at this point, I don't like the fact that I've got buffers all over the place. And I need to go back to test. So I'm just going to exit. And the very first one is on line... Wait. Where is 1, 2, 3, 1, foo, 3? Assign index, assign... I'm looking for, how about this, where the word pass. Okay. So it's down here, it's 1078. So on line 947, when executing this one, it did 3 instead of 3 high. Why? Have no idea. That's a very good question. Let's figure that out. So all that I'm going to do is I'm going to say cout p. Now I know why. Well, I don't know why, but I'm going to investigate this first. I don't care about the fact that I've got a loop somewhere else. And I can just kill this in a moment. Okay, what I want to see is what's happening. So null string jump 22. By the way, I'm just going to edit my source program -dump bytecode. Not dump. Well, I probably need dump as well. What I was going to say is for copy, I get +=2. Okay, that's fine. And now if I edit source program execute and go to copy. Oh no, I'm doing +=2. Okay, there went that idea. Let's go back to what I was doing. So what's happening on this print? So I've got null val. That should be my print 2 then 1. String of high, jump to 22. Okay, jump to 22. Boom. Now, one of the things, copy, it's calling copy on both of these, and neither one of these should be called copy on. So why is it calling copy? Well, we're going to edit the source of the AST node function declaration, because that's where all of the work is being done. And we've got this copy stuff. Okay. Get identifiers assigned is getting name added to them. If the count, I mean, it's not getting added, it's saying that it exists in the set. It should not exist in the set. So why is it getting added? Well, in order to do that, we've only got two places we can look. One is the source for AST node assign. Did I do it in the binary? I shouldn't have, but AST node binary. Did I just do it in the wrong place? Yeah, this shouldn't be on the left-hand side. Who did this? Say, you did, Corey. No, 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 no. I definitely didn't. I wish. So I don't think this is going to fix it. Actually, I'm wondering if I should do a make clean. Anytime I'm dealing with the opcodes, I've got something wrong. I've still got the copies. But wait, 3 is working now? Oh, no, wait. No, it's not. P3 is not working. And there, forgot I needed to kill it. And I think, so this is in the compile, excuse me, in the AST node assign. I'm editing the make file. I might as well edit the test CPP. Why? Because, well, I still have that C out, but I don't care at the moment. So we're like 1077. The pass by value versus ref. This is the one that I care about. And now, the bottom, when I run the test, I want to call with gtest filter is equal to function dot and I think I'm gonna yeah. Now that I edit a make file, it's I'm just have to exit. We're just running the one. That's the whole point of this. Just running and it passed. No, 0 from 0. Should that be a capital? Capital F for function. So it didn't pass. Okay. Don't know what we need to... Well, we can... Here we go. Let's see what all is here. We've got a null val. That's going to be change and then A. Jump to 42. So this is our function. We are calling copy. Why did it fail? It got 1, 2, 3, 1, 2, 3. Oh, because we didn't copy? The copy didn't work? Maybe? Well, we still don't know why it's always copying. But copy 0 should have... We've got two problems. Let's identify which one first. I think I want to go back to this one here. This was it function compiled? Yes. Function compiled. And do cout. Was it P2 or P3? Function.compiled. Oh well. Just edit the make file on the right hand side. There we go. And now, so P3 on 947. Yeah. That one didn't. So if I cout just we're still getting copies, and because we're not changing them, we shouldn't be getting the copy opcode. That's a problem. So now we have to figure that out. Left hand side. So I said that there's only two places. One is the... I'm going to add, when we create this P3, just cout Ah, can't type to save my life. There. So it's flanked by those. And now we're going to edit the source AST node assign. The left-hand side is getting that. And you see, okay, that's fine. The reason I'm doing this is because we're about to be outputting some stuff and it's probably going to be messy. My apologies ahead of time. Can I, when I edit the source AST node identifier, all I'm going to do is say cout this arrow name and then a space and then state. Is it going to complain if I do that? Hope not. All right, so what I care about is this here. Print 2 then 1 has a state 0. That's a 0. Do you know what I did? I know what I did. It did exactly what I asked. It did a bitwise OR, and it should have been a bitwise AND. But, well, I'll go ahead and write this. And it's now passed. And look, there is no copy. Okay, fine. So there's no copy, and we get the right value. Well, that was just my stupid operator error. So now, let's figure out why this isn't, or why this is giving us problems elsewhere. For the make file, what I bet is if I want to just get rid of it. Yeah, I will. Because now I don't think that it's broke. Well, if it goes into an infinite loop, we've got a problem. But I think I know where the issue is, and it has to do with the computed expression for an array when we make a copy. I think we're about to find out. Okay, so pass by value versus ref failed. We've got all this. Okay, I need to remove the couts and stuff there. And that's in 1. So I can just... it's going to do this again. But why? So it gave us 1, 2, 3, 1, 2, 3. Let's see what's happening. So here is the function, pass by value versus ref, or the code, the script. And again, we are getting the copy is happening. Copy 0, it's even happening in the right place. Peak 1. What is 1? Oh, foo. Peak 0, which should be a copy. Integer 1, assign index. Okay, all of this is right. It looks right. So I think the problem is, first of all, in the copy for an array. So what we're going to do is we're going to say edit the source for a computed expression array and make copy. Should this be a deep copy? The answer is yes. So what is this contents? We need of all array elements. So it's going to be a auto, no, not an auto. It's just easier to say a vector of garbage collected called new contents. New contents dot, is it reserve or resize? I don't remember. Oh, I should just pull this over here. C++ vector come on, just a C++ reference. That's all I need. Reserve. Reserve how much? This arrow contents dot size, because I'm about to do for auto const ampersand item in this arrow contents new contents dot push back item arrow make copy. And now new contents. Still didn't pass. I know that this needed to be done, but so the question is our copy code working? Are we changing what we think we're changing? And I think the answer to that's probably no. So we've only got one place in this entire test file where we're copying. So now we still have to do what we just did, but let's look at the bytecode for the copy. That's right here. We're doing the stack of fp plus position is equal to stack back make copy. So the stack, whatever, no, it shouldn't be stack back. Who wrote this crap? It should be stack of fp plus position dot make copy. Look, it passed. So the copy worked. That's great news. All right, let's remove this cout stuff. And So what all does this test tell us? It does a couple things. Number one, it shows that, you know what? I should just put this here. Test shows one, I don't know. What it shows is that argument is correctly copied. Number two, array argument is correctly copied. Does not modify outside scope. And I mean, I was thinking there was a number 3. Well, yes, there is. And that is, I'm going to add back the cout of p1.dump bytecode. Why? Because one of the things I'm kind of wanting to ensure is that number 7 is actually a copy instruction. So byte 7 is a copy instruction. And maybe I shouldn't do it on this. Maybe it should be, you know, let's do it in a separate one. So 21 test shows argument produces the copy opcode. And all that I'm going to do is say val, and here val is equal to 1. That's all that I need to do. Function a there. p1 dot get bytecode dot at, because it's going to give me a constant one, so at 7 should be opcode copy. Of course, what is opcode copy? It's probably going to give me an error there. Oh. Opcode has not been declared because we haven't pound included it. And is that a problem? I think it is with pound include tang.hpp, and the include of tang.hpp does not include the opcodes. Oh, I don't know how to compare opcodes. Really? Don't know how to compare. Oh. The easiest way is is 1109 is to tell it, yeah, this is supposed to be a U integer T. That's 7. Why? Oh, probably because it's... it's no longer at position 7. There we go. It is at position 3. That passed. Now, what I should do is argument produces a does not produce copy opcode. And all I need to do is to call this a B. There we go, not equal. Okay, that should be right. So we've got a test demonstrating that it works. We've got a test showing that when I've got A being reassigned, I get a copy opcode. And when I've got a different variable, I don't get one. Now the question is just want to verify this. Cout p1.dump bytecode is number 3 the one that we should be looking at? Or does it need to be 4 or something? Oh, and that's right here. So jump, we've got a null, an integer 1, so it is 4 that should be. Why? Because this, well, 3 is reserving the spot for B. And so even though we'd used 3 in the previous one, if it was going to copy or wrongly copy, it would be at position 4. So that needs to be a 4. All right. We are passing all the tests. Is there anything else we need to test? Now there might be further optimizations that could be done. For example, the fact that we're passing in integers. We might have some function called needs deep copy that we could say, oh no, it's just an integer. You can't modify the value. There's nothing inside it to modify. In which case we could then say, I don't need a deep copy, just yeah, I don't need a deep copy, just do my, what am I trying to say? Just give it myself, right? So don't worry about copying me, saves a memory operation, all that. Well, that could be something down the road that we could look at as an optimization. But for now, I think that we are at a place where we can... Oh boy. Anytime you have a refactor, you touch a lot of places in code, and we'll just let that run while we look at our code. Git diff. Then we're going to see a lot of these where we added the preprocessed state. All of this looks correct. Red and green, very festive for Christmas. When I'm recording this, it's not quite Thanksgiving, but I already have my Christmas tree up. Why? Because I had family in and they helped me put it up, and it was nice. Oh, we got rid of a to-do. So that's nice. All right. Woo. Add pass by value instead of ref when arg will be modified in scope. Sure. 48 files changed. Oh boy, 219 lines written, 75 deletions. That was 75 was the refactor. So how many actual lines written? 219 minus 75. That's how many. So was that 154 something or 144? I don't know. Math is hard. I didn't add any files, so let's just do make docs-pdf. Let it reuse some stuff. See, it's I think it's hopefully going faster. Maybe not. I don't know. For episode? What episode are we on? You know me. I never know. Episode 43. And git tag. What's it called? .043, our message is going to be the same. Episode.043. We've pushed it. It is there. It is live. And just counting our lines of code, where are we? 5,300 lines. 2,000 lines of comments. I can live with that. It's not a bad ratio. It's going to get worse. Why? Because we don't comment a lot of the tests. Maybe we should. Maybe I'll start adding. I think I do like the scoping approach when writing the tests. So I think that's pretty good. All right. Well, we've come to the end. If you've stuck around for the roughly 2 hours, a little over 2 hours that this has been, thank you. And again, I hope it's overall that it's educational in some way. Again, the goal of this, it's not to entertain. I know that this is a long format thing, but it's more for you to see the process of maybe what's going through my mind as I'm trying to write a programming language and seeing, okay, what are the steps? What am I having to think through? And partially it's just C++. How does it need to be structured? So object-oriented programming and some of the modern C++ features that are required in some places. So, yeah, overall, just hope it's been good. As always, thank you. Have a great day, and I'll see you next time.